In this video, I will use the ratio test to show that the series with the expression n to the third over n plus 4 factorial converges, and then I'll also show that the series converges to negative 35e plus 571 over 6. So let a sub n be the expression n to the third over n plus 4 factorial. A sub n plus 1 is n plus 1 to the third over n plus 5 factorial. The ratio a sub n plus 1 and a sub n would be this expression over this expression. And then n plus 4 to the third is the same as n to the third plus 12n squared plus 48n plus 64. N plus 5 factorial is n plus 5 times n plus 4 factorial. This factor n plus 4 factorial and this factor n plus 4 factorial, they will cancel each other out. So the top, we just get this expression right here, n to the third plus 12n squared plus 48n plus 64. And then for the bottom here, we get the n plus 5 times n to the third. So we get n to the fourth plus 5n to the third. So the limit of the ratio a sub n plus 1 and a sub n as n approaches infinity, it would be the limit of this expression right here. And now let's divide everything by n to the fourth. N to the third dividing by n to the fourth is 1 over n. 12n squared dividing by n to the fourth is 12 over n squared. 48n dividing by n to the fourth is 48 over n to the third. And then here we get 64 over n to the fourth. And then n to the fourth dividing by n to the fourth is 1. 5n to the third dividing by n to the fourth is 5 over n. And then we can see that as n approaches infinity, each term here will approach 0, and then the 5 over n also approaches 0. So for the whole thing we get 0, which is less than 1. So the limit of the ratio a sub n plus 1 and a sub n as n approaches infinity is less than 1, and therefore by the ratio test, the series with the expression n to the third over n plus 4 factorial converges. And now let's show that the series converges to negative 35e plus 571 over 6. Using what's called partial fraction decomposition, I'm going to write the expression n to the third over n plus 4 factorial as some constant a over n factorial plus some constant b over n plus 1 factorial, and then plus some constant c over n plus 2 factorial, plus some constant d over n plus 3 factorial, and plus some constant e over n plus 4 factorial. And for the term with the constant a, we can rewrite it like this, so that we get n plus 4 in the denominator. And then the term with the constant b, we'll rewrite it like this, and we get n plus 4 in factorial in the denominator. The term with the constant c, and the term with the constant d, and then the term with the constant e, we'll leave it as it is. So now we can see that each expression here has a denominator of n plus 4 factorial. So what this means is that we get n to the third is equal to the sum of all the numerators here. And then now we can solve for a, b, c, d, and e. So this equation right here is true for all n. And so we let n be negative 4. So when n is negative 4, this will be 0, this will be 0, 0, and 0. So we get E is negative 4 to the third, which is negative 64. And to find D, we can let n be negative 3. When n is negative 3, then we'll get negative 27 for the left side. And n negative 3, when n is negative 3, this will be 0, this will be 0, and this will be 0. And then negative 3 plus 1, 4 is just 1. And so we get D, and then plus E. But E is minus 64. And so D will be 37. And I'll let n be negative 2. And then this term right here will be 0. This will be 0. And then when n is negative 2, we get 1 here and we get 2 here. So 1 times 2 is 2c. And then here, negative 2 plus 4 is 2. So we get 2d and then plus E. E is negative 64. D is 37. 37 times 2 is 74. And then here we get negative 8. And so C will be negative 9. And now let n be negative 1. Then we get negative 1 for the left side. And then when n is negative 1, this will be 0. And here we get 1 times 2 times 3, which is 6. And here we get 2 times 3, which is 6. And then here we get 3d and then plus E. Once again, E is negative 64. D is 37 times 3, so it's 111. And then C is minus 9 times 6, so it's minus 64. So we get B to be 1. And then now let's use n as 0. So we get 0 for the left side. And then here we get 24a, 24b, 12c, plus 4d, and plus E. So here's 24a. 24b is 24 times 1, which is 24. C is negative 9, so 12 times negative 9 is negative 108. D is 37 times 4, so it's 148. And then E is minus 64. And then A will come out to be 0. And so A is 0, B is 1, C is minus 9, D is plus 37, E is minus 64. And then this is our original series, and we can rewrite it as sum of these 4 summations right here. And then we just have to find the value of each summation right here. Recall that the power series representation for e to the x is 1 plus x squared over 2 factorial plus x to the third factorial, and so on. E to the first, that's when x is 1, so let x be 1. Then we get 1 plus 1 plus 1 over 2 factorial plus 1 over 3 factorial, and so on. And then move these two terms, the first two terms are here to the left side. Then we get e minus 2 is equal to this sum that starts with 1 over 2 factorial. And then if we move these 3 terms right here to the left side, then we get e minus 5 halves is equal to the sum starting at 1 over 3 factorial. And then similarly, e minus 8/3 equal to the sum that starts with 1 over 4 factorial. And then e minus 65 over 24 is equal to the infinite sum that starts with 1 over 5 factorial. Therefore, the series with 1 over n plus 1 factorial, which is this series right here that starts with 1 over 2 factorial, so it's this one, so it's equal to e minus 2. 1 over n, the series with 1 over n plus 2 factorial is the series that starts with 1 over 3 factorial, which is this sum right here. So it's e minus 5/2. The series with 1 over n plus 3 factorial is the sum that starts with 1 over 4 factorial, which is e minus 8/3. And then the last one is the series with 1 over n plus 4 factorial. It would be the sum that starts with 1 plus 5 factorial, so it's this one, which is e minus 65 over 24. Here's our original series again, and then we rewrote it as sum of summations right here. And we have just shown that the series with 1 over n plus 1 factorial is e minus 2. The series with 1 over n plus 2 factorial is e minus 5/2. The series with 1 over n plus 3 factorial is e minus 8/3. And the series with 1 over n plus 4 factorial is e minus 65 over 24. And then simplify everything, and then we get negative 35v plus 571 over 6, which is approximately 0.268. And so in summary, the series with the expression into the third over n plus 4 factorial converges by ratio test, and then it converges to negative 35v plus 571 over 6. And that's the end of the video.